We'll take question 4, where you have to find what is the smoke temperature right here after the evaporator but before the superheat. And what we know is that we have 275 degrees coming out of our chimney, and so actually we have the energy coming out of our smoke plus the energy coming out of our economizer plus the energy coming out of our superheater. That way we can count how much energy there is right here, and then we have to find the smoke temperature. But first of all, then we have to find out what is our volume, what is our mass in our smoke, and which we will do a mass balance. We have how much air that's coming in plus how much fuel that's coming in. That mass balance, well, that will tell us how much our flue gas weighs. So let's do that. We do that right here. The energy in the smoke is mass smoke times specific heat capacity in smoke times the delta T. So the mass in the smoke is the theoretical smoke use times what extra air we use, so all the oil molecules can find an air molecule times the mass of the fuel plus the mass of the fuel. So we can have a look at it here. Well, we have a mass balance. This here we calculate into seconds. That is the mass of the fuel. That's one of them. The other one is the air. That's more complicated. Well, we have 14 kilo of air. If every oil molecule has, theoretically, if every oil molecule has to find an air molecule, but we need to put in some extra air, so we're sure that all our molecules, oil molecules, react with the air. So therefore, we put in a factor 1.1 extra. So actually, the amount of air is 14 times 1.1. That is the air. So now we can calculate it. This is here is the amount of air, and this here is the amount of oil. This is the mass balance. So we have the fuel plus the oil. Well, that's equal our smoke. 10.8 kilos per second. 10.8 kilos per second is running this way up. And now we know that, then it's a little more simple. So we go back to calculate what is our energy just before our superheater. Well, that's the energy in our smoke plus the energy in our economizer plus the energy in our superheater. So we say mass smoke times specific heating capacity smoke times T smoke plus the mass of steam times the delta enthalpy from the economizer plus the mass of steam times the delta enthalpy in the superheater. That is equal the mass of smoke times the specific heat capacity times the temperature of the smoke. And you put in some volumes, some values, and then you get this. Okay. Yeah. First of all, I would like to show you this one here. This is what we use in question 3. The amount of energy is 100%. It's our chemical energy, our fuel energy. And then it goes to different places. And when we talk about boiler, then yeah, you calculate a lot of it goes into the steam here in this process. Then some of it leaves in our chimney. Then we also have radiation loss. That is our heat transfer to the surroundings. That's typically around 2% for oilers. And question 3, calculate the smoke loss and radiation loss. Let's see how that is done. Well, the smoke, that was actually quite easy. We have the volume per second of smoke, and we got the specific heat capacity for smoke, same right there. And then we have the smoke temperature -20. Well, 20 comes from the air we put into the combustion is 20 degrees, therefore it's minus. And then we just calculate that, and we got it. We have previous. Oh, well, yeah. So we have the amount of energy put in, and we have the smoke energy. That's 10%. And 100%, that was the amount of energy, and the 88%, that was coming into our boiling water, minus the 10%. That's leave without smoke, and leaves the radiation loss of 2%. Yeah, that was it. Well, you're gonna get more of these assignments, so don't worry. Yeah, so it's good.